In my previous two videos, we learned how to find the greatest common factor of two numbers using the listing method and using prime factorization. Today we are going to find the greatest common factor not just of numbers but also of polynomials, which also include variables. Let's start with the binomial 8x minus 24xy. In this example, we don't have just numbers, we also have variables. So we have to find the greatest common factor of the numbers and additionally the greatest common factor of the variables. The greatest common factor of the numbers 8 and 24 is 8. Because the 8 divides into itself and into 24. There is no greater number that divides into 8 and 24, so the 8 is the greatest common factor of these numbers. If you have trouble seeing that, you can also factor the 8 and the 24 into their prime factors. Feel free to watch my previous video, how to find the greatest common factor using prime factorization. So we can write the 8 with its prime factors as 2 times 2 times 2. And the 24 as 2 times 2 times 2 times 3. The product of the common factors of 8 and 24 is 2 times 2 times 2, which is 8, which is the greatest common factor of 8 and 24. The next step is new now. What is the greatest common factor of the variables? To find the greatest common factor of the variables, we have to take out as many of the same variables as possible in both terms. Ask the question, do we have an x in both terms to take it out? Yes, we have one x in both terms, so let's take it out. Do we have a y in both terms? No, unfortunately, the y is only in the second term, so we can't take it out. So the only common factor is the x, because the x is in both terms. The 8 is the greatest common number, and the x, let's say, is the greatest common variable. So the greatest common factor of 8x and 24xy is 8x. 8x divided by 8x is 1, and 24xy divided by 8x is 3y. You can verify this by multiplying 8x by 1, which is 8x, and multiplying 8x by 3y, which is 24xy. Let's look at another example. What is the GCF of 2x to the fourth y squared plus 6x squared y? Again, let's find first the GCF of the numbers and then the GCF of the variables. The GCF of 2 and 6 is 2, because 2 is the greatest number which goes into 2 and into 6. So we put the 2 in front of the parentheses. Let's look at the variables. In the first term, we have x to the fourth and y squared, which we can write as x times x times x times x times y times y. And in the second term, we have x squared and y, which we can write as x times x times y. Now we have to take out as many of the same variables as possible in both terms. Both of these terms have at least 2x multiplied by itself, And we also have at least one y in both of the terms. So let's take the 2x multiplied by itself and the y out. We put x times x, which is x squared, and the y in front of the parentheses. Now, 2x to the fourth y squared divided by 2x squared y is x squared y, and 6x squared y divided by 2x squared y is 3. If it's easier for you, you can also ask 2x squared y times what is 2x to the fourth y squared, and 2x squared y times what is 6x squared y. What about this polynomial? 18x to the fourth y cubed plus 42 x cubed y squared. Let's first find the GCF of 18 and 42. 18 is 2 times 9, and 9 is 3 times 3. 42 is 2 times 21, and 21 is 3 times 7. Common factors are 2 and 3. Which is 6. So the GCF of 18 and 42 is 6. Six times 3 is 18, and 6 times 7 is 42. What about the variables? Can we take x to the fourth out of both terms? No, unfortunately we can't, because we only have an x cubed in the second term. So let's take x cubed out of both terms. X cubed times x is x to the fourth, and x cubed times 1 is x cubed. What about the y? Feel free to pause the video and try it yourself. The GCF of y cubed and y squared is y squared. Y squared times y is y cubed, and y squared times 1 is y squared. Let's solve the last example. 3x to the fourth y z squared plus 27 x y squared z minus 54 x y z. Feel free to pause the video, grab some pen and paper, and try this yourself. Let's try this with prime factorization, which is a great tool to find the GCF of 3, 27, and 54. The 3 has just the number 3 as a factor. The 27 we can write as 3 times 9, and 9 is 3 times 3. And we can write the 54 as 2 times 27. 27 is 3 times 9, and 9 is 3 times 3. So the greatest common factor of these three numbers is 3. 3 times 1 is 3. 3 times 9 is 27. And 3 times 18 is 54. We can't factor out x to the fourth because in the second and third terms we only have x. So let's factor out the x. What about the variable y? We only have one y in the first and in the third term. So we can't factor out y squared. And in the second and third term, we also only have the z. So let's take out the z and put it in front of the parentheses. 3xyz times x cubed z is 3x to the fourth yz squared. xyz times y is xy squared z, and xyz times 1 is xyz. And we are done with this problem. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning, everyone.